Hello. Hi guys. Good morning. Ki hal chal? Sab changa si. I hope that you guys are doing good. In this video, we're going to number of dice rolls with target sum. Although it's marked as medium, but I'll say it's an easy problem considering you are able to at least reach on to what the problem wants you to do. Cool. Let's quickly jump on to what the problem says. And again, it has been asked by Google, Apple, Amazon, like big threes, big fours, in last 2 years. So it's a good important problem. It's a standard, like you will see that firstly we understand, and then we go on to intuition, and then we'll go on to solution itself. So it just says that we have n dice and each dice has k faces. So in general you can imagine that the normal dice which you have has 6 faces. So just imagine that you have such dices and each dice has k, so the faces also can be many, and every face is numbered from 1 to k. So a standard dice, as it is numbered from 1 to 6, so every face is numbered from 1 to k for each of these n dices. Now I am given 3 integers n k. Okay, n other number of dices, k are the number of faces. Target is the sum which we want to achieve. But bhaiya, how sum? See, if you have some dices and some numbers on top of it, so I can just say, okay, I have n dices, I will just face up some number out of k faces, and then I have to sum that up to achieve to a number called as target. So I have to return the number of possible ways, again, out of k raised to the power n total ways. Now firstly you would have a question, bhaiya, how this number come up? We will go on to it, and that will be our starting part of the intuition itself. But if we go on to the question itself completely, then it says that number of possible ways we have to figure out of these total number of ways, such that sum of the face up numbers, again for n dices we have k faces, so face up number is just a one number, so sum of the face up numbers should be summing up to the number called as target. And again, the number of possible ways can be pretty large, so just do a modulo with 29 plus 7. So we will just, as usual, pick a natural example from the question itself and see that how can we do it. Again, we have not understood the entire question properly. There was this part where you still had a confusion how these number of ways are as the total number of ways. So if we take this example where n equal to 2, which means I have 2 dices as I have shown you, and each dice has k faces, and for sure you can see that each dice, as you can see, 3 on the visible side and 3 back on the non-visible side, right? If I just draw it completely, so it will look something like this. Now I have to achieve the target as a number called as 7. So I have to just figure out the number of possible ways. But coming on back, we will firstly figure out the total number of ways. And again, total number of ways are, see, the problem is saying it is k raised to the power n. But how? So if I have the first dice, I can have k possible numbers, I can have k possible faces, so I'll place every of these faces one time. Okay, it's up, one time it is up, so I have k possible ways to face up this first dice, and again k possible ways to face up the second dice. So in total I will have k into k as the possible faces for this n dices, right? So you saw, okay, k for the first dice, k for the next dice, and so on and so forth. For every dice I will have k options to place my face up, and this every face up will give me a number, and that every number I can simply add that and achieve my target. So in this you can easily see that so it will be keep on multiplying for all the dices, and we know we have n dices, so the answer will be k raised to the power n. Now if we go on, okay, that was the intuitional way, but mathematical way will be, if you see that, okay, for the first dice I know that I have k equal to 6, right? I have 6 faces, so for the first dice I will just put, okay, face up as just 1. So for the second dice I will have 6 options. So with this, okay, 1 1 it will give me a sum of 2, 1 2 it will give me a sum of 3, 1 3 it will give me a sum of 4, 1 4 it will give me a sum of 5, 1 5 it will give me a sum of 6, 1 6 it will give me a sum of 7. So you saw that just putting a face as 1 on the first dice, and then I can just vary the second dice. So and the same will go on, okay, 2 3 4 5 and 6. So you saw k options here, k option next side, so it will be nothing but k square. Or directly I can say that I will have k raised to the power n total number of ways. Now, this will be the backbone of how you will go ahead with your question itself. Now, you saw that on every dice, I am just trying to place a number, and then when I placed a number, I will go and place another number on the second dice. It's just that one constraint is there for us, that we want to achieve our target as a specific target value. So let's say I'm saying I want to achieve the number as target, which means my sum should be achieved as target. So I'll just do the same thing. I was at the first dice, so I'll just name the dices as the dice indexes. So I just have my dice indexes from 1 to n, just saying I have n dices and I'm currently on the first dice. When I'm currently on the first dice, I had 6 options. I have k options, right? I have, okay, either I can place a 1 or a 2 or a 3 or a 4 or a 5 or a 6. If I have k faces, if like here the k was 6, if I had, let's say, 8 faces, so I will just have gone the k faces side. So on the first dice, I had k faces for the first dice, so I have k options to place a number on the first dice. That is what I can easily say. Now when I placed a number, what ultimately I wanted that to achieve this target. So ultimately, in the very beginning, I am at the very beginning, which is the, let's say, the first dice itself. Here I am saying that I want to achieve the number called as a target number, but as soon as I placed a value, let's say 1, now my target which I need to achieve is target minus 1, and again here it is target minus 2, here it is target minus 3, because I placed number 3. So now my new aim to achieve is target minus 3. Now my new aim is to achieve target minus 4. So again, remember, I had to go on to all the dices. That was the first case for me. Now other case which specifically the question was saying is to get and achieve the target. That is the reason I'm going on to all the targets for us. Okay, all the targets. So that is, I'll see, okay, target minus for target minus. It is the next thing which I need to achieve. Okay, now again, from here, from this option, when I placed a 1, now I have my dice index is on the next value. I have to now place my dice index on this specific next value itself. Again, I will have k options, as in 6 options. So let's say it would have been a very big tree, so I did not draw it, but let's say you would have drawn it. Again, the 6 for the next one, the 6 for next, the 6 for next, and so on and so forth, right? If I draw just one for each of them, let's say if I draw and place a number 2 on the second dice, so ultimately it would have said that the new achievable value should be target minus 3. Let's say if I am saying I would have another dice also, let's say I have n as 3, so new achievable value should have be target minus 3. Or if you are saying, bhaiya, okay, I had 2 dice, so okay, ultimately you achieved a number which was target minus 3. If this number is a 0, then I would be saying, okay, I achieved a number which is target. But if this is not a 0, then okay, my next achievable number which I got is target minus 3. If I had more dices, I would have reduced my target much more further. But okay, if you are saying that this is the end of the dice, so I was able to achieve my number as target minus 3. Maybe, and for us to get the answer, this should be a 0, which means I should be able to achieve a number as target, right? So this should be a 0, so as to get okay, I have achieved a number which is equal to my target. And as you saw, the target in this question was actually the number 7. If I go back, 7. So okay, this would not give me a correct value, but this is just to showcase that if we build the entire recursion tree, and let's say for the case number 2 which we saw, if by chance I place a number 1 on the second dice, then my achievable target, next target to achieve will be become again target minus 3. So you saw something. I was on the second index, and with this I go on to the third index, right? Let's imagine for now I have more than three dices, like let's say 3 or more than 3 dices. So if I am at the third dice, I will say, okay, my achievable value is target minus 3. Again, for him also, if I'm at the third index, or basically if I'm saying indexing is 1 based, so if I'm at the third index, again for the code itself I will take indexing as 0 based, so it will be from 0 to n minus 1, right? Now, but anyways, it's just for explanation, that if I am on the third, and again I'll say I want to achieve the number called as target minus 3. So you saw this index is same, achievable value which they need to achieve is also same, and for sure k is constant, which means any way whatsoever you will try for all the k options, that is fixed for sure. So you saw that you have a repeating sub problem. If we go much more deeper, then again in this second dice, for this third case, in this second dice, let's say I placed a 2. So next achievable value should have been target minus 5. If again I place a number 1, so next achievable value should have been target minus 5. Again, for this third index, for the third dice, as in achievable value is target minus 3, target minus 5, which is again saying I have repeating sub problems to achieve. Again, if we go on to the last, let's say if I place a 3, I place a 2, higher achievable value is again same. So this is just one cases I showed you. Again, it will have many more repeating sub problems, because I just showed you one case out of all 6, or basically k possible phases which I can place. I just placed one value, but I can place k values. So in these only I can see the repeating subproblems, and that's the reason it's just a simple recursion tree with some repeating subproblems. And as we know, the main state is nothing but I have to go on to all the indexes, as in all the dices, and on every dice I will have k phases to place on. As soon as I place any phase, I will have some remaining target to achieve, and thus I will be knowing, okay, as the case fixed, I will have to try on for all the case, for all the states of dices. So this is fixed, so I just have only 2 states, which is okay, the dice, as I have to go on to every dice, and also the remaining target, which means currently, okay, if I have placed a number, let's say phase value 1, so the remaining value will be remaining target minus 1, which I have to achieve considering going forward. And thus you will see I will have only n target in my DP state, but the time complexity will be n into target into k, because for every state I will have to go on to all the phases of my dice. And again, spaces O of n into target, because you saw that I have just n target. Now constraints are n is 30 and target as 1000. If we sum up, then our base condition will look something like, if I have completed all the dices, as I showed you, if I have completed all the dices and this remaining target value, if this is equal to 0, and this remaining target value, if this is equal to 0, which means it's great, I should return, it's a one possible way. And at any point of time, if my remaining target becomes less than 0, so please return a 0. Now bhaiya, why is this required and how to even know it? Okay, this you explained while we were solving the entire recursion tree, we solved it. But bhaiya, how to know this? Simply, this would be required. If you don't write this and you will just write the entire program what you thought, it will give a runtime error. Why? Because it will try to go and check for this memoization, because in a DP, which is in a memoized DP, what do you check? After doing it, you just check, okay, if this is already there or not. So you will check in dice index and remaining target. If this remaining target is less than 0, so any indexing attribute which is less than 0 in C++ and Java will give you a integer overflow. Basically, it cannot handle negative indexes, right? That's the reason it will give you an error. So just to handle that error, as soon as my remaining target becomes less than 0, so simply return a 0, because for sure if less than 0, then okay, I have no possible ways. Else you can just check the simple memoization, which we do. Now a very standard recursive case which we have, we go on to all the phases, and for all the phases I know I will go and check if I place that value and if there's a good value or not. So I'll just go and add in my answer, okay, if it's a possible way, it's a possible way. I will have this recursive function called as solve, in which for the current dice index, I placed this phase value. So for the next index, as in next index onwards, what is the remaining target? It is remaining target, let's say current is, I am at the current index with the value as remaining target. So if I place the phase at the current index, so for the going forward basis, which means for the that dice index plus 1 basis, I will have my remaining target minus face value as the new achievable target which I want to achieve. And this is the only recursive case which you have to see, and that is obvious also because you have to have all possible k faces. Ultimately, the code is pretty simple. Firstly, we have to handle the mod, so we just took the mod with us. Now when we have this mod, the two base cases as I showed previously, exactly same as we have written. Memorization part, it is just simple memorization part, and also while returning the answer, simply assign it into dp. Now the actual recursive case is you try on for all the possible k faces, and for every k and for every face you just said, okay, at the current dice index and the remaining target, if I place this face value, so for the dice index plus 1, the new target will be remaining target minus face, and that's it. These two are just the functions to actually help us, like n and k. That's it. Now in my actual case, I just initialized my dp. So you saw that I have initialized, obviously I have declared my dp as global so as to use in my recursive function the same way I just did. I just initialized my dp with a size n plus 1 and target plus 1. Bhaiya, why n plus 1 target plus 1? Because you saw that my dice index, if this is reaching n, so I am comparing n, and also the remaining target, this target value, it will be initialized from the target itself. So if I have, let's say my target is 4, so my array needs to initialize, should have an index of 4. Index of 4 means that it should have 5 blocks. 5 blocks means it should have target plus 1, or basically target plus 1 number of blocks it should have to achieve the index as target, right? And the same way I did this, initialize the value minus 1, and ultimately I just called my solve function with the initial dice index, and as I showed you, my dice index is from 0 to n minus 1. As soon as my all dices are finished, which means I have reached the nth, like I have passed all the n minus 1, I have passed all the n dices, I have surpassed my n minus 1 index of the dice, which means now I am at the nth index, which means it is the n plus 1 of the dice. So I will say, okay, my all n dices are complete. Now if you are on this index, which means all the n dices are complete, now just go and check if the remaining targets should also have been 0. And thus ultimately I initialize my dice index with 0. Target is the base target, and I will just keep on decreasing with the face value so as to achieve this target as a 0 ultimately when I would be reaching my end. And these are just the helper values. Again, time is actually o n into target, space is actually o of n into target. Cool. I hope that you got good. Bye bye. Sorry for the voice, my voice is bad.